Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Okay, guys, so welcome. This is Shah Fahad Khan, and now today we are going to start out a very invaluable series of lectures on O levels chemistry. 5057 is the syllabus code for this subject of CAIE, and the very first chapter that we're going to start out is experimental chemistry, and the subchapter or the subtopic is experimental design. So let's get started, and guys, stick around because I have very important stuff to give you in this series. Okay, so especially for those who are appearing for the O levels chemistry exam this year or the upcoming years. So let's get started. Okay, so let's first familiarize ourselves with the apparatus that are used in our syllabus for O levels. Okay, so for the measurement of time, what is the apparatus that we are going to use? First of all, you must know what SI unit for time is. Okay, what does SI stand for? Well, SI actually means the International System of Units, basically the unit that is used throughout the world as a standard. Okay, the standard unit for time used across the world, used by the chemists across the world. In fact, also the physicists around the world. Okay, so now time, which is measured in the SI unit, the SI unit for time is seconds. Okay, so this is the standard of time measurement, and the symbol for seconds is S. And the instrument to measure time is stopwatch. Okay, this is the standard instrument that we are also going to be using in our school labs. Well, in O levels you don't have the lab, you have your alternative to practicals. Well, you do have labs in some schools, but in most of the schools you go for ATP, and in the ATP the apparatus that you are going to, when you are asked to identify the apparatus used for measurement of time, it's going to be stopwatch. Okay, so this is the first point you need to remember. Okay, stopwatches are of two types. There is an analog stopwatch or a digital stopwatch. Well, this doesn't really matter. It's a digital stopwatch that is usually available to us in the labs, but this is how the analog stopwatch looks like. Well, the difference in between them is their accuracy, the digital and the precision. The digital stopwatch is more precise and more accurate as compared to analog stopwatch. And precision and accuracy, well, precision means the smallest unit of time that the instrument can measure. Basically, the digital stopwatch can measure up to 2 decimal places, analog can measure up to 1 decimal place, but that doesn't really matter here. That doesn't really concern us in chemistry. That's a topic of more concern in physics. So when we'll be doing the videos on physics, then we'll talk about precision in more detail. Okay, right now just ignore this term precision. Just know what it is. It's just the smallest unit of time that can be measured by an instrument. Okay, but just remember that these are the two instruments that we can use for measurement of time. Okay, and what is time, by the way? Time is in fact a physical quantity, a quantity that can be measured, and by definition it is just the interval in between two events. Okay, so the time interval in between two events is known as time. Now let's move on to the next part. Okay, now there are some other units of time as well, such as minutes, hours, but since they are not the standard units, so we are not going to talk about them in more detail. It's the seconds that is more important to us. If you have any calculation in chemistry or in physics, so the answer for time should be in seconds. Well, usually the unit is given to you, but still it should be in seconds. Okay, that's the standard. If you have to measure the time, it's going to be measured in seconds, but you should know the interconversion between seconds and minutes and hours. 1 minute equals 60 seconds, and one hour equals 60 minutes, and 1 hour equals 3600 seconds. Well, I've written all of this down over here, but still let's read through this page. But they are not the standard units. Okay, if you are asked to identify the SI unit of time, the SI unit of time is seconds. Okay, always remember. Now other instruments for time measurement are also present, such as a pendulum clock or a ticker tape timer, etc. You will find these examples in physics books, but again, they're not very important for chemistry. Now let's move on. 1 hour equals 60 minutes, and 1 hour equals 3600 seconds, and 1 minute equals 60 seconds. And I'm assuming you guys know this by now. Okay, now moving on. Okay, so let's talk about temperature. What is temperature? This is now the second quantity. Okay, the second physical quantity that we are going to talk about, temperature. Okay, so what is temperature? Temperature by definition is the degree of hotness or coldness of a body. Okay, and the SI unit is Kelvin. Okay, it's not degree Celsius. Degree Celsius or degree centigrade, this unit over here, it's not the SI unit for temperature. It is a unit. Yes, we can convert Kelvin into degree Celsius or degree Celsius back into Kelvin, but again the SI unit is Kelvin. And remember one thing, the Kelvin, when you are writing down the unit for Kelvin, there is no degree sign with Kelvin. Okay, like over here, like degree Celsius has a degree sign over here, but there is no degree sign with Kelvin. No degree sign with Kelvin. Okay, if you put a degree sign, then it would become incorrect. Okay, so please be careful about that. And this is the interconversion in between degree Celsius and Kelvin, and you must learn this. Okay, 1 Kelvin equals degrees. The temperature in Kelvin, if you need to calculate the temperature in Kelvin, just take the temperature in degrees Celsius and add 273 to it. Okay, and this is one example. If you have 0 degrees Celsius, then what is 0 degrees Celsius equal to in Kelvin? How many Kelvin is it equal to? Well, for that, it's simple. To calculate the temperature in Kelvin, just add the temperature in degrees Celsius to 273 and you'll get your answer. The answer is 273 Kelvin. So 0 degrees Celsius equals 273 Kelvin. Simple. So you can also do a few practice questions for yourself. Okay, now let's just move on. This is not very difficult, I hope so, but still very, very important. You do have questions of interconversion between Kelvin and degree Celsius. Now, mercury. Okay, wait, this is not mercury. This is mercury in glass thermometer. Okay, this entire term is one thing. This is one instrument. This is the instrument that is used for measuring temperature, the very common one that we have in our labs, in the school labs. It is easily available. Well, not, yeah, actually in the school labs, we do have it. So now let's go on reading this part as well. Mercury in glass thermometer is usually used under school lab conditions. Okay, the standard used in school labs. Other instruments for measuring the temperature include the thermocouple thermometer. You're going to read about this in more detail in physics. The temperature sensor connected to a data logger. Well, temperature sensor is just a metallic strip that is connected to a machine, and when you place that strip into some solution or into any substance that you want to measure the temperature of, that data logger will give you a digital value of temperature for that. Now coming down, how to calculate the range of a temperature. Well, if you want to calculate the range of a temperature, what is range? Range by definition means the difference between the maximum value of that temperature, means the maximum temperature that thermometer can record or that instrument can record, minus the minimum temperature that thermometer can record. Okay, for instance, if this is a mercury in glass thermometer, and if I want to find out the range of this mercury in glass thermometer, I'll need to have its maximum temperature, basically the maximum temperature that it is capable of recording, and I'll also need to have its minimum temperature, the minimum temperature that it is capable of recording, and then I'll just subtract them and find out the difference, and that will give me the range. And here's an example of it. The mercury thermometer measures the temperature from minus 10 degrees Celsius to 110 degrees Celsius, and this is actually a real life thermometer that you use over there in your labs. Okay, this is the standard thermometer that you use in your school labs. Okay, it has a range from minus 10 to 110 degrees Celsius. Each division on the scale of this thermometer represents 1 degree Celsius. Okay, so you can each division represents 1 degree Celsius. So the accuracy of this type of thermometer is plus minus 0.5 degrees Celsius. Okay, what do I mean by all of this stuff? Now let me explain that. If this temperature measures from minus 10 degrees Celsius to 110 degrees Celsius, what is this value? This is in fact the range of that thermometer. Okay, although I haven't subtracted it, but this is still the range. And if I wanted to calculate a value of the range, then I would take the difference. And how to calculate the difference? The maximum minus the minimum. So maximum is 110 minus the minimum. What is the minimum temperature here? Is it 10 or is it minus 10? It's minus 10. So I'm going to place the minus 10 in brackets. Okay, so the minus minus, when you multiply them, it becomes plus. And so 110 plus 10 is going to become 120 degrees Celsius. This is the range of this mercury in glass thermometer that we're talking about. Okay, the range of this mercury in glass thermometer is 110 degrees Celsius, 120 degrees Celsius. Okay, and now they told us over here that this thermometer, it can measure up to 1 degree Celsius, meaning the smallest division on this thermo scale is 1 degree Celsius. So the formula for calculating the accuracy of thermometer is just simple. You just take the least count or the least division and you divide it by 2. This is how you calculate the accuracy of the thermometer, which is 0.5 degrees Celsius. This isn't that important for your theory questions, theory papers, but it is very, very important for your ATP or practical papers. Okay, in the ATP papers or the practical papers, they do ask you to calculate the accuracy of the thermometer. So this is how you're going to calculate the accuracy of thermometer. You just take the least count of that thermometer and divide it by 2, so you get the accuracy, which is plus minus 0.5 degrees Celsius. Plus and minus, what do the plus and minus indicate? Well, the plus and the minus. Plus means that each value that you record, it can either be 0.5 degrees greater than the actual value, or it can be 0.5 degrees less than the actual value. Or for instance, let me just take a, okay, let me write it down over here. If you have recorded a value, let's say 25 degrees Celsius, okay, so it's not important that you've actually calculated 25, you've actually measured 25 degrees Celsius accurately. And why am I saying that? Because the least count is 1 degree Celsius. So where can the accurate, the exact, where can I be very sure that the accurate, what's going to be the range in which the accurate value will lie? So it's going to be plus and minus 0.5 degrees Celsius. So this in fact tells me that the accurate value actually lies from 24.5 to 25.5 degrees Celsius, right? This is where the accurate value will lie. But it won't lie below 24.5 or it won't lie above 25.5, but rather it can be anywhere in this range depending upon my measurement technique. Okay, but when I give you 25 degrees Celsius alone without this, so it's not a very accurate value. To give an accurate presentation of that value, or to give or more scientific way of writing down that temperature, is with its least count. Basically its precision, or with its uncertainty. This is called uncertainty, but in fact you'll be learning about this in detail in physics in AS. But still, let me clear this out to you guys, that for your ATP, especially for your ATP exam, you should know what the accuracy of this sort of temperature thermometer is going to be. The thermometer that has a 1 degree Celsius reading, or 1 degree Celsius least count, its accuracy is going to be half of the least count. Now let me show you the thermometer. This is how the thermometer looks like. This is the long yellow thermometer over here. This is your with the temperature scale written on top of it. This is your lab thermometer that you'll find in your labs, and this is a clinical thermometer. And of course, the clinical thermometer, you can see it's quite shorter than the long lab thermometer. So of course, that's the one you use in clinics. So if I were to ask you to compare the clinical thermometer with the mercury thermometer in labs, how are you going to tell? The very first thing that you need to notice about them is their temperature scales. The temperature scale of a laboratory thermometer is way larger or way longer than the clinical thermometer. So that in fact tells us that the laboratory thermometer can measure a temperature over a wider range as compared to a clinical thermometer. Okay, and this is how the data logger along with the temperature sensor looks like. Remember, I talked about the data logger and temperature sensor somewhere over here. Yeah, right over here, this one. temperature sensor connected to a data logger. So this is how it looks like. This is a data logger, a machine, and this is a temperature sensor, and they're connected to each other by this wire. So the temperature that is sensed by this temperature sensor is recorded in digits on this data logger. But again, this is not very important. Moving on. Okay, now coming to the next quantity, mass. The third quantity is mass. The first was time, the second is temperature, and then now the third one is mass. Now, mass is pretty straightforward. First of all, you should know the definition of mass. What is mass? Well, mass is a measure of the amount of substance or matter. Substance means actually matter, okay, in the body. So this is the simplest definition of mass, in fact, and still very important. You are still asked, especially in a few MCQs, to define mass, etc. In physics, of course. In chemistry, they don't ask you much, but still. And the SI unit over here is kilograms. It's not grams, okay? Remember, it's not grams, it's kilograms. This is the SI unit for measuring mass. Now, other units are also there, but still they are such as grams, pounds, etc., ounce, etc., but they are not important for our syllabus. This is the more important one. You should know the interconversion between kilograms and grams, and of course, I'm sure a lot of you would know it. 1 kilograms equals 1000 grams. And in fact, when I'll give you the link to the interconversion of prefixes in physics videos. So over there, I have given a more detailed account of how to convert between kilograms or megagrams or other units, the different prefixes of physics. So please do watch those videos, because after them, these interconversions would be on your fingertips. Okay. Now, instrument for measuring include the electronic mass balance, or the beam balance, or the sliding mass balance. Okay. So from these three balances, I would suggest you remember this and this one. And why am I saying that? Because there have been questions on them in the past papers. Of course, I know these are pretty straightforward, just the names of the instruments, but still, you need to know them. And in fact, when you come in your AS and when you have actual labs, then you'll definitely see the electronic balances as well in the labs. Now, moving on to volume measurement. Okay, I think this video is gonna go on longer, so I'll talk about volume measurement in the next video. Thank you so much.